Write the heading, define time period of satellite. Define time period of satellite. So whenever we talk about period, that means something which is repeating, that is periodic. So when satellite revolves around Earth, it will repeat its path again and again and again and again. So time taken by a satellite to complete one revolution. Time taken by a satellite to complete one revolution is called as time period of satellite. So time taken by satellite to complete one revolution is called as time period of satellite. Right definition? Time taken by satellite to complete one revolution is called as time period of satellite. Okay. Derive expression for time period of satellite. Derive expression for time period of satellite. What is formula for speed?
Distance upon time.
Distance upon time. So can you tell what will be time equals to?
Distance upon speed.
Speed.
Distance by speed.
Correct. If time is time period, then distance covered will be for one revolution. Can I say it is circumference of orbit? है ना? Time taken to complete one revolution is circumference of orbit. Okay. What is time period denoted by? Capital T. Correct? Time period capital T.
Yes, sir.
Yes, sir.
And circumference is 2 pi r.
2 pi r.
Speed is nothing but critical velocity ka magnitude Vc. So if I know Vc, I get my formula. So I'm starting from beginning now. Consider a satellite of mass m moving in a circular orbit around Earth with critical velocity Vc. Since speed equals to distance upon time, so circumference of orbit upon speed, speed is Vc. Please copy now till this.
Done, sir.
Okay, everybody has done till t equals to 2 pi r upon VC.
Yes,
Yes.
sir.
Okay. Therefore, t equals to 2 pi r. VC means root of Gm by small r. That is 2 pi r root of r upon Gm. See, can I write r as root of r square? Pranjali, can I write like this?
Yes, sir.
Can I write a as root of a square?
Yes, sir.
Yes. So I take r inside, it will become r square into r upon Gm. Therefore, t is 2 pi root of r cube upon Gm. This is an expression for time period of orbiting satellite. Yeah, complete till this. This is an expression for time period of orbiting satellite. Hello? Ah, wish you happy new year. Thank you, thank you. आज काम नहीं लगता ऑफिस का क्या आज छुट्टी दी आप लोगों को हाँ, हो सकता है, हो सकता है। हाँ, अच्छी बात है ना भाई। चलो जाओ। अरे यार अपन तो घर पे ही है। आप बाहर हो लगता है। आप बुलाओ तो आ जाता हूँ मैं बाहर यार, उसमें क्या है? किधर मिलूं बोलो? अरे भजन करेंगे, भजन करेंगे। ओके। हाँ हाँ, नीलेश आप घर पे हो ना? मैं आपको 12:30 करता हूँ फिर से बोल। ओके। हाँ हाँ हाँ, चलेगा। बाय। ओके, बाय बाय। Yes, completed. This is an expression for time period of orbiting satellite. Completed till this?
Sir.
Avan, suppose they say, show that t square is proportional to r cube. Then what you will do? T square proportional to r cube. This they ask. What you will do? Avan?
Let's third law, no?
Pardon? Avan, you can't hear me?
Square on both the sides.
Squaring on both the sides.
Correct, squaring on both the sides. So sometimes they don't ask derive expression for time period of satellite, but they will say show that t square is proportional to r cube in satellite. So I will say squaring both sides. Squaring both sides we get t square equals to 4 pi square. This will become r cube upon gm, correct or not?
Yes.
Now, is 4 pi constant or variable? 4 pi square, constant or variable?
Constant.
Constant. What about G and M? Capital G, capital M. They are also constant.
Constant.
Yeah,
Constant.
correct, correct. So we can say since 4 pi square G M are constants, therefore T square equals to constant into R cube. So T square proportional to R. Sometimes they can ask you this. So please complete 3-4 lines more further. Very important chapter for entrance. Those who have taken, those will be only trying for CET, law of motion, motion in a plane, and gravitation are included in entrance.
Done, sir.
Square proportional to R cube, we have already completed. Graph of T square versus R cube. Graph of T square versus R cube. Whenever you want to draw the graph, whenever we have to draw the graph, then current what we should start with?
X and Y.
Chalo, current Goel, you say how to start with?
So we have to plot t square and r cube on x and y axis.
That means first I should know equation connecting t square and r cube.
Hmm.
Equation is t square equals to 4 pi square upon gm into r cube. This we have to plot along y, r cube along x. ये मैथ्स के हिसाब से किसका इक्वेशन है? According to maths,
Straight line.
straight line. Very good. Any type of straight line or particular straight line?
Passing
Particular.
the origin.
Passing through origin, correct. So this is expression for straight line passing through origin. Straight line passing through origin. So if I take t square along y-axis, r cube along x-axis, so my graph will be straight line passing through origin. Can you tell what will be slope? Yes, Isha, Neha, Trupti, Arya, Pranjali, what will be slope? Nandini, what is slope?
Tan theta.
Tan theta.
No, no, no. Look the equation properly. Tan theta is general formula.
So 4 pi square upon gm.
Superb. 4 pi square upon gm is the slope. So this they can ask you in the exam MCQ. In the graph of t square and r cube, what is slope? 4 pi square upon gm. Now copy for it.
Done, sir.
Sir, just a minute.
Yes, yes. Completed?
Yes.
Okay. One note write down. For satellite orbiting close to Earth's surface, small r, which is r plus h, will become only r. I hope you followed this line. Everybody has followed this line?
Yes, sir.
What is formula for t square? 4 pi square
Guys,
upon gm
GM
into
into
small r.
RT.
Small r, can I write capital R? Because it is orbiting close. We can, na?
Yes, sir.
Now this gm, can I write r square g? Because g formula is gm upon capital R square. Ayman, can I write this? In place of gm
Yes,
r
sir.
square g? Okay.
Yes, sir.
Now this r square ka cube may cancel. So time period t is 2 pi, taking square root of r by g. So when it is orbiting close to Earth's surface, then time period is given by 2 pi root r by g. ये 2 pi root L by G सुना है आपने formula anytime? Anay, have you heard this 2 pi root
For
L by G?
pendulum.
Pendulum? Yes.
Yes, sir.
So this is also like pendulum only, but L will become R. Okay. Yes. Vaishnavi, are you there? Mentally present?
Yes, sir.
You sent paper today. So you thought in New Year day you will send the paper? Your test paper you sent today, I think.
Yes, sir. I forgot
Af-
to write
After
that.
exactly 1 week. If you forget, then suppose you become a doctor as MS, that means Masters of Surgery. So you'll forget Caesar in the stomach of the patient and open after 10 days.
No, sir.
No, not the
Sorry.
same. The same way do this also here. This small lethargicness from your side will reduce your mark. Don't be lethargic. Be active. What is your blood group? Be positive.
Yes, sir.
Then enjoy. Okay, right. All of you write till this.
Done, sir.
Define gravitational intensity. Define gravitational intensity. So whenever we say intensity, that means actually strength. Every magnet has some strength, every person has some strength, every charge has some strength. So if I want to check my strength, खुद को मार के देखूं क्या सामने वाले को मारूं?
सामने वाले को।
अगर उसने बजा दिया दो तो उसका स्ट्रेंथ ज्यादा क्या मेरा ज्यादा है?
उसका।
उसका
उसका।
ज्यादा है। उसने हाथ पकड़ लिया खाली तो दोनों मुकाबला टक्कर का है क्या नहीं?
Yes, sir.
So whenever we want intensity of any mass, it should apply force on the neighboring mass. So we say force acting per unit mass is called as gravitational intensity, denoted as E. What will be unit? Newton per kg, correct? Force is Newton, mass is kg. So intensity of M1, can I say is force acting on M2? And intensity of M2 will be force acting on M1. Not followed. Not followed.
Sir, please
Yes, sir.
repeat one.
M1 को अगर चेक करने का है उसका स्ट्रेंथ कितना तो किसको फोर्स देगा? M2 को ना. तो इट इज फोर्स एक्टिंग ऑन M2. अगर M2 को चाहिए तो किसको देगा?
M1.
तो फोर्स एक्टिंग ऑन M1. क्लियर?
Yes, yes.
ओके. जनरल में क्या है? फोर्स अपॉन मास. राइट. द फोर्स acting per unit mass is called as force acting per unit mass is called as gravitational intensity. It is given by E. G. E means intensity, G means gravitational, is force upon mass. Its SI unit is Newton per kg. Its dimension is, can anybody tell what will be dimension? Newton is M1,
M0,
L1. Very good, very
L1 T
good,
minus
very good, very good. M0, L1 T minus 2. It is scalar or vector quantity? Force matlab vector na? So it is a vector quantity. Okay?
Yes, sir.
Right now. Very simple chapter we are doing. There is concept of vector present when we start with MCQ. Once you complete, please tell. Huh?
Done, sir.
Okay. Derive expression for gravitational field intensity. Derive expression for gravitational field intensity. Consider a body of mass m at a distance small r from center of earth. Consider a body of mass m at distance r from center of earth having mass capital M. Therefore, by Newton's law of gravitation, gravitational force between two masses is given by G mm upon r square. Any doubt till this? I think it is very simple. Consider body of mass m at distance r from center of mass capital M by Newton's law of gravitation. Gravitational force F equal to G m1 m2 का जगह पे mm लिखा है. Okay? Here?
Yes, sir.
Yeah, please write this much, then I'm explaining further.
Done, sir.
We are not interested in force, but we are interested in intensity. So gravitational intensity of mass small m comma Eg is force acting on capital M. That is G mm upon r square into capital M. Capital M I can cancel. G m upon r square. So this is formula for gravitational intensity. Gm upon small r square. Write down. Written full? Yes, completed. Nandini?
Yes.
Okay.
Yes.
Next one. Define gravitational potential. If this is Earth, body is here, mass m. Will this body be pulled towards the Earth by gravitational force?
Yes, sir.
And Earth will be also pulled by the body by same gravitational force. That's why they become cancer and body remains stationary. If I go on moving away at infinity, what is gravitational force at infinity? At infinity, what is gravitational force?
0.
Zero. Very good. Zero.
0.
Because R infinity matlab G mm upon infinity square will become 0. So if there is no force at infinity, I can easily move any mass na, without any opposition.
Yes, sir.
If I easily move, am I doing any work? नहीं ना, फूक मारा तो भी जाएगा ना वो, because there is no opposition. So am I doing any work?
No.
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 But when I come closer in the gravitational field, then if I apply some force, it will be pulled downward. Some force, it will be pulled downward. So work done in moving a mass from infinity to a point in gravitational field is called gravitational potential. Here work done is 0. Suppose here work done is 10 joule. So 10 joule is nothing but my potential at that point where I have made the body stationary. So if 10 kg के लिए 10 joule potential, 1 kg के लिए कितना आएगा? 10 joule upon 10 or not?
Yes.
So that work done per unit mass is called gravitational potential. In electricity, it is work done to move unit charge. Here, unit mass. So work done to move unit mass from infinity to a point, in gravitational field is called as gravitational potential. The work done to move unit mass from infinity to a point in gravitational field is called gravitational potential. Write down. Exactly same thing you are going to see in electrostatic chapter. Mass will become charge. That's it.
So can you explain again?
Write down. Again, I'm explaining. First write down, then I will clear the screen and explain it. Don't worry.
Done, sir.
Seven.
Yeah.
Done, sir.
Let us see once again what is meaning of this. I said suppose there is some mass here at infinity. At infinity, what is force? Zero, na? If force is zero, then work done is force into displacement will become zero or not. This much follow?
Yes.
Yeah. So always at infinity there is no stored energy. आपका एनर्जी का कुछ काम नहीं है, आप घूम सकते हैं बिकॉज देर इज नो अपोजिशन. लेकिन जैसे ही ये मास को ये अर्थ के फील्ड में लाया तो अर्थ इसको पुल करेगा ना.
Yes, sir.
तो कुछ अर्थ पुल करेगा मतलब मुझे बचाने के लिए कुछ तो काम करना पड़ेगा. अर्थ खींच रहा है अपने तरफ, मैं अपने तरफ खींचू, तो अगर मैं अपने तरफ खींचू अर्थ का अगेंस्ट ग्रेविटी, तो स्टोर्ड एनर्जी होगा क्या? नहीं.
Yes.
उसको पोटेंशियल बोलते हैं. तो इधर से इधर आया, अगर ये 10 जूल है, बट पोटेंशियल भी डिफाइंड फॉर वन सिंगल के लिए कितना. अभी कोई भी दुकान पे जाएंगे, आप रेट पूछेंगे तो 1 का बताएगा क्या 100 का बताएगा वो? हेलो, व्हेन वी गो इन
एक का।
शॉप, हाँ 1 का बताता है ना. तो ये वर्क डन 1 के लिए मतलब टोटल मास से डिवाइड करना पड़ता है ना. अगर m के लिए w, तो 1 के लिए कितना? w अपॉन m, है ना.
Yes, sir.
तो यही क्वांटिटी का नाम क्या है? ग्रेविटेशनल पोटेंशियल. वर्क डन टू मूव यूनिट मास फ्रॉम इंफिनिटी टू अ पॉइंट इन द ग्रेविटेशनल फील्ड. क्लियर?
Yes, sir.
Now, if W is work done to move mass m from infinity to a point in gravitational field, then gravitational potential comma V equals to W upon M. Can you tell what will be its unit? Don't say volt, huh? Volt electrical potential hai. What will be unit? Looking at this, can you say?
Joule by kg.
Joule per kg. Yes, joule per kg. Correct. Now write further. Its SI unit is joule per kg. Copy full and write SI unit joule per kg. It is a scalar quantity.
Done, sir.
Right. Derive expression for gravitational potential. See, when we say derive expression means it is in terms of distance, gravitational potential. Potential means indirectly work, huh? Work done. Okay. What is potential? Stored energy. That means work done. Correct or not?
Yes, sir.
To get
Yes.
total work done, when we use integration, when force is constant or when force is variable, when we use
Force is variable.
Variable.
in case of gravitational force, is it variable or it is constant? Think and say. Is it variable or constant?
Constant.
No beta. R अलग अलग points
Variable
पे अलग
R.
अलग मतलब इधर
Yes,
अगर
sir.
दो, that means it is variable. If it is variable, if it is variable, then I cannot use direct formula, na? I have to use integration, correct? So that between very small distance dx, this force remains constant. So first I will find dw, then I will integrate, I will get w, then I will divide by mass, I will get potential. This is my logic. But to get dw, do we require force or not?
Wow.
So we will start from force, and to get force we require one mass or two mass.
Two.
टू, एक अर्थ का और एक दूसरा वाला जिसको मूव करने वाले. So I can say consider a body of mass m at a distance of x from center of earth having mass capital M. Consider a body of mass m at a distance x from center of earth. Therefore, gravitational force F equal to G mm upon x square. Now, if I move this body by distance dx, then work done will be force into dx, plus or minus. Work done will be plus or minus. Hello? This work done will be plus or minus?
Plus.
Plus, because force is pulling force and we are moving in the direction of force. So let body of mass m be moved by distance dx against by distance dx in the direction of force F. Therefore, dw work done, comma dw is force into displacement ds. So dw is g mm upon x square into ds. Let the body be moved from infinity to a point at a distance small r, here I am writing two line, small r from center of earth. Okay, please copy till this, then I am finding total work done by integrating dw from infinity to distance r. Draw diagram and then proceed, copy till that.
Done, sir.
So early. Diagram and that full.
Sir,
Huh?
Done, sir.
Everybody has done? Full?
No,
Yes,
sir.
Yes, sir.
Okay, I'm just clearing first part if everybody has not done. Wait, see further. Therefore, total work done, comma W is integration of dW from infinity to bring the point up to R. This is nothing but G upon x square dx from infinity to R. So G you take constant outside, dx upon x square from infinity to R. So work done is G integration of x raised to minus 2 dx from infinity to R. So work done is G What is x raised to minus 2 ka integration? X raised to minus 2 ka integration? Hello? X raised to minus 2 का इंटीग्रेशन
-1.
हाँ एक पावर बढ़ाओ ना डिवाइड बाय सेम पावर ये ना अपना फॉर्मूला we have
Yes,
done
sir.
so -1 I am taking outside, so inside I will get x raised to -1 from infinity to R, that means minus gmm 1 upon x from infinity to R. So this is minus gmm. How to solve this? Wherever you see variable, put upper value, that is small r, minus 1 upon infinity. 1 upon infinity means what?
0.
0. So we get work done W equals to minus gmm in bracket 1 by r minus 1 by infinity, which is 0. So W equals to minus g mm 1 by r minus 0. So W upon small m will become minus gm by r. W upon small m is nothing but gravitational potential. है ना? Hello?
Yes, sir.
That is
Yes, sir.
gravitational potential V is minus gm by r. पूरा कर लो इतना सॉल्व. So we got E का formula gm by r square and V का formula minus gm upon small r.
Sir, what is the last sentence? That is
Gravitational potential. That is gravitational potential.
okay.
So everybody has completed full?
Done, sir.
1 minute.
Yes, completed na full?
Yes, sir.
Okay. So I'm just clearing this, okay? So that's all for today. This topic will not be in